Hello everyone, let's draw the Lewis structure of ammonia, that is NH3. We first need to count the total number of valence electrons in ammonia. The atomic number of nitrogen is 7 and the electronic configuration is 1s2, 2s2, 2p3. The 1s2 are core electrons and the 2s2 and 2p3 are valence electrons, and that means we have 5 valence electrons in nitrogen. We have only one nitrogen atom, and for hydrogen the atomic number is 1 and the electronic configuration is 1s1. Therefore, we have one valence electron, but we do have 3 hydrogen atoms, and therefore 1 times 3, that is equal to 3. So, 5 plus 3, 8. In total we have 8 valence electrons in ammonia. Let us draw the Lewis structure now. Even though nitrogen atom is more electronegative than hydrogen, we have to put the nitrogen atom at the center here, because the hydrogen atom always comes at the end. And let us put 2 valence electrons each between nitrogen and hydrogen, so that we can make 3 chemical bonds, and we still have 2 more valence electrons, and that becomes 1 lone pair. Let us check for the octet configuration. Here the central atom, that is nitrogen, does satisfy the octet configuration. Hydrogen atom can take a maximum of 2 electrons, and therefore each hydrogen atom does satisfy the duet configuration. This is the best Lewis structure that we can draw for ammonia. Or we can also make a bond between nitrogen and hydrogen, and we can represent it this way. The actual structure won't be like this because of the lone pair bond pair repulsion. The actual structure will be trigonal pyramidal for ammonia because of the lone pair bond pair repulsion, and the bond angle among hydrogen, nitrogen and hydrogen will be approximately 107 degrees in the case of ammonia, and the hybridization of the central atom is sp3. Let us calculate the formal charge of nitrogen and hydrogen in ammonia. We know that formal charge is equal to number of valence electrons in the atom minus number of non-bonded electrons in the molecule minus number of bond pairs divided by 2, and therefore the formal charge for nitrogen is equal to, we have 5 valence electrons in nitrogen minus we have 1 lone pair, that means 2 here, minus we have 3 bonds and therefore 6 by 2 here. So, this will be equal to 5 minus 2, 3 minus 6 by 2 is also 3. Therefore, formal charge for nitrogen will be 0. How about the formal charge of hydrogen? We have only one valence electron minus lone pairs 0 minus we have only one bond for each hydrogen, and therefore, this is 2 by 2. Therefore, the formal charge for hydrogen atom, each hydrogen atom will be equal to 0. So, this means that the formal charge in ammonia for both nitrogen as well as hydrogen will be 0.